Okay, so and then sometimes like as humans, like if we see a 10-minute video, we're more likely to see it as opposed to seeing like an hour and 10-minute video. It's kind of like, ugh. So that's why I also break them down. I can help you after the lecture. What's that? Yeah, okay, so we were talking about or trying to understand like functions, right? So functions load onto memory main, and then like if main, there's another function called here like echo variables, another function called then echo variables also loaded. And today we just went a little deeper. We here notice here I just put like number 10, right, to represent this parameter value. But today we went we zoomed in and we're like, well, what's really happening? So that's what's really happening, right? But again, we'll stick to this convention because I mean it's kind of like a little overboard if I make you all do the 4 bytes represent. That class is not, this class is not for that. So, but at least hopefully now you're getting an understanding of why the stack is called the scratch pad for programming, because it's always functions loading and unloading, data variables loading and unloading. So that's why it's known as the scratch pad. Okay, so let me go on, and now we can talk about the next data type, which is a double. We're not going to worry about mapping a double to memory. That's 8 bytes, okay? But you make sure you at least remember that, right? Integer is 4 bytes and double is 8 bytes. And maybe you're asking, well, how do we know that? Can we like have some proof of that? And the answer is yes. So let me see here. Orange space roll. So let me open my code space here. So last time we were working with whole numbers, and recall in this class, we're just gonna focus on integer, whole numbers, double, decimal values. It's in essence like a larger float, right? It's a float that can hold like larger precision and larger number. Character and string, those 4, that's enough to show you fundamentals of programming in this course. We're not gonna take it any further. Okay, I'm waiting for this to load. Actually, I think I did go over decimals, right? Yeah, I was showing that we can use decimals, and if we're using decimals, we have to be very careful when we use them because of the computer architecture, the way computer stores data. Like to us, we might be seeing 2.1, and we're saying is 2.1 equal to 2.1 in a test case, and then it fails because behind the scenes, the computer might have like on one side like 2.105 and then on the other side like 2.1. So then they're not equal. What we're seeing is not how they're stored in memory. So we have to be careful with that. If you run into that situation, and you will in the homework assignment, the solution is multiples of tens or multiples of hundreds or multiples of 1,000, right? To convert that value on the left side to whole number and then the value on the right side to whole number. Afterward, you can compare them. So that way you don't get into problems. So. Okay, so let me see here. Okay, so I think that's it for that. Okay. In Python, you don't have to tell Python data type you're going to use. Like you just create a value like num equals 10. Behind the scene, Python's like, okay, you want to use whole numbers. And then if you want to assign a value 10.5 to num, then Python's like, oh, you're a float now. Okay. And very flexible. C++ is a strongly typed language, meaning when you create a variable, you have to tell C++ what you're dealing with, right? So I'll explain. Like, so let me go here, for example, with integers, right? So remember, we create a whole number integer, and then we're like, hey, I want to use it as a double now, or decimal number value. C++ is not so friendly. Like we have to, we get into like what's known as casting, right? Which is what Python does behind the scenes. But we have to be careful, because if we're like using like 10.99 and then we want to use it as an integer, then C++ will let us use it as an integer, but it will get rid of the decimal value. So we'll look at an example that explains that to us, right? And we have to be careful with that. So let me see here. I don't think it's in this one. It is. I guess it is. No, it's here. I'll jump back to auto in a little bit, but I wanted to, let me see here. No. Thank you. I'll jump to that example that I just explained a little bit, but let me continue on the same path that I was explaining for Python, right? So I was saying that in Python, you can create, like, obviously this won't run on C++, but I'll just write some code. You can do that in Python, and then you can do this, and Python's happy. And then you can even do like, you can do this, and behind the scenes, Python's like, oh, you want to use different data types with the same variable name. Perfect, I will help you. C++ will not work like that, okay? C++ is a community. They were losing a lot of developers before modern C++, so then they came up with, I guess, a workaround. You don't have to declare the data type, meaning you don't have to say like int num equals 5 in modern C++. However, once you tell C++ that you are working with whole numbers, then you're stuck working with whole numbers with this variable, not num, right? You have to work with numbers. But what C++ did is like, okay, so say you don't want to worry about data types, then you can use the keyword auto, that's a keyword in C++, and then you can let C++ determine the data type. And notice it is a num, a whole number int. So from this assignment, C++ is like, oh, okay, so you are a whole number. But if we use a decimal value, then it'll treat it as a double value, right? So what is this here? Double num. So, and if we put a single quote around that's character, one character, then it'll treat it as one character. Not Python, but they were trying to at least like make it easier for programmers, so we can do that. And here, I guess what I'll do is I'll just create 3 different variables just to show that. There's no test case for this, okay? So let me make sure that I can output something. So I have to include IOStream. And then I'll say that I'm using from the standard library namespace the cout object. And I'll just say integer and then the value for num. \n means like new space, a new line. So then I'll say auto num1, and I'll say like 10.5. Then that would be a double value or decimal value. So we say cout. So I'll put double value, right? So that's the data type name. And then I'll say num1 And once you create them like this, it's like creating int num10. You can use it in arithmetic operations, expressions, and this one too, okay? Finally, we can say character 1 equals like the letter, actually anything, right? It could be an alphanumeric number, it'll still work. And then we want to show that it's character and char1 or car, depending on who you talk to. And we can execute this program. However, just remember, to run programs, you go to CMake and src. We're still in examples, and we are in data types. We were using the auto keyword, and then we can run this piece here, run in terminal. And that's what we have here, like integer, double. So we're letting C++ determine the data type for us, nothing. However, I cannot go in here and expect to do this, right? So notice that there'll be no error, but then C++ will ignore the 0.5, and we'll see that in a different example, right? So here, when you say integer, just remember you're dealing with integers, okay? Not dealing with decimal values. So we have to be careful with that. So let me commit this as one check-in. And that's it for this example. It's just to show, I mean, in the homeworks, if you're like, I don't want to mess around with data types, you can use auto. C++ will take care of the rest for you. I don't care if you use auto or you declare the data type, same difference for me. But the recommendation for modern C++ programmers is to use the auto keyword, right? So I'll go ahead and push. So that should be in my repository. Okay, so using the auto keyword. So let me go ahead and